Hey guys, today's physics lesson, I'm not going to really teach you anything. I'm actually going to show you how to implement all those rules that our teachers have taught us, and all those rules that I've shown you how to do. So today we're going to do a question on projectile, and these are the most common questions you'll get. So the first one is going to be a horizontal projectile, and let me draw this for you. So the first type of question is horizontal projectile, and over here we have a situation where there's a man standing here at the top of a cliff, and he jumps down the cliff, which is 36 meters long. Okay, so this is the end of the cliff. And now at the end of the cliff there's a ledge that's 6.4 meters long. And now the question is, what would be the requirement of minimum initial velocity or minimum velocity to clear this ledge and not die? Alright, let me repeat myself. 36 meters in height, 6.4 meter ledge. How much inertial velocity does he need to clear it? So the first thing we do is, when we see a horizontal projectile, first thing I write is u equals ux. Why? Because we have him running in this direction with initial velocity, right? U equals ux. Why? Because u is moving in this direction, this horizontal direction. In the beginning, u is not moving in this direction whatsoever. It will move in that direction later, but initially it's not moving in this direction. So the next thing I write is uy equals 0 at the initial point. Alright, next I write down what I know. Acceleration in y equals minus 9.8. We'll keep it like that. Acceleration in x direction equals 0. That's what we know. And then one thing to keep in mind is that I'll call this one height. Yeah, the y direction, some of you guys call it y, I call it height. So height is minus 36 meters. And remember, from the previous videos I've told you, anything in the y direction can be negative. Where you are right now, where the person was initially at, that's your 0 meter marker. When he moves down 36 meters, he's moving down by minus 36 meters. That's a crucial fact. Okay, and then he needs to clear 6.4. So I'll write x equals 6.4 meters, and that's all that's given. That's all that I know. Oh, and angle theta is 0 because I'm moving in this direction. I'm not projecting up or down, so we don't need this. Okay, so they said, how much initial speed would he require to not hit this ledge? Now, looking at what we have, we're going to use the direct formula. X equals uxt. Simple. That's pretty much what we're going to do, because 6.4 and that, right? So x we know as 6.4 meter equals uxt. Now the problem over here is that t is not known and ux is not known. Ux is basically in our initial speed, so instead of ux I'll just write ut. Now we don't know these values, so what we do is we use the formula of height. Okay, so what I'm going to write is h equals uy t minus gt square. This is what we write. Okay, and now we know that uy is 0. Okay, so if we just put this here, t is cut, h equals minus gt square. Alright, this is only in the case of horizontal projectile because you don't have uy. I explained it just a few seconds ago. Now we input the values we know. Height is minus 36 equals minus 9.8 t square equals minus 36 by minus 9.8. See how the minuses and minus cancel out? This is why I told you anything in the y direction can have a negative value, so calm down. Sorry, my bad, absolutely sorry, I'm very sorry, but I wrote the equation wrong. It's going to be g by 2 t square by 2. Oh my god, this is so unprofessional. Times 2, and then moving the times 2 over here would give me times 2. I'm very sorry, this was very unprofessional, but it would be gt squared by 2 minus gt squared by 2. This is how it goes, and then there's a divide 2 over here. I'm sorry I couldn't find any space. And when you rearrange it, it will be times 2, and your answer should be 7.34, and t would be 2.71 seconds. Alright, we have the time, and now let's input this time into this. Okay, so we know x equals ut. We've already established that. So x, which is 6.4, equals u times 2.71. So if you rearrange it, 6.4 by 2.71, 2.36 meter second minus 1. Or I'll approximate this, and there's a good reason to approximate this, is because they said they want the minimum velocity required to clear this zone. Yeah, so this is the velocity required to hit 6.4, which is not what we want. 2.36 is what's required to hit this thing. So if you round it to 2.4, it's what's required to clear that thing, and hopefully the man doesn't die if our calculations are right. Thank you for watching this video. This was a really quick video, and this is a question from the Physics Edexcel AS book on page 37, question 2. Thank you for watching.